afternoon, everyone. And today is the third live class on numerical methods for engineers. And to begin with, we'll just have a quick recap of what we did so far in the previous class and see what we are going to learn for today's class. Okay. So, in the previous class, we had gone through the linear algebra basics, and we also saw the row picture and the column picture, and we were introduced to the concept of hyperplanes. And we also understood what is meant by finding the solution of several equations, okay, or a set of equations. So we also saw the row picture and the column picture of the point when we are trying to solve these equations, okay. So, and probably Rohit, the other TA for the course, had taken up on rank and pivoting and ill-conditioned matrix and Cramer's rule. And I had also explained a few algorithms on Gauss elimination and LU decomposition, okay. The mechanism and one example probably Rohit took up. So in today's class, we will be focusing on another iterative method to find out Ax equal to B, and we will understand why are we trying to do this. So we will learn the Jacobi method and the Gauss-Seidel method today. And I guess these are the topics which is included in your assignment 3, whose deadline is approaching. And we'll also go through 3 more direct methods as asked by a few learners in the doubt forum. So we will go through Gauss elimination, LU decomposition, and Gauss Jordan, see what is their exact algorithm, and then we will go forward with the examples. Okay. So let's get started with today's class. So can any of you or both of you in fact unmute and just tell me why are we trying to find out Ax equal to B and why are we trying to solve Ax equal to B? So first we need to understand what we are doing. Okay, so then we'll proceed with today's class. So can any of you just unmute and tell me the reason? You can hear me? Have I lost you both? Okay. Yeah. Vignesh, would you like to give an idea about why are we solving Ax equal to B?
To find the unique solution of the equations.
Right, that's one of the great answers, that we are trying to find out unique solution of the equations. Okay, and any other idea, Tejal?
Maybe for prediction.
I didn't get you quite. Can you repeat?
For prediction.
Prediction of, as in prediction of the solution, you mean? Like what will solve the equations? Predicting that?
Yes, sir.
Okay, okay. Both of you are right. In some sense, both of you are right. Okay. So we will take a broader picture, as we'll first go with the point that Vignesh pointed out. He said that to find out unique solutions. Okay, so imagine if this is your coordinate system, x and y axis, and in case you have two lines passing through, drawn in the coordinate system such a way that they intersect at a point. Okay, only when they intersect at a point you can find a unique solution. Fine. If they do not intersect at a point, what if two lines superimpose on each other? If two lines superimpose on each other, you have infinite solutions, not just one unique solution. Okay. And what if you have two lines which are parallel to each other? So if they are parallel, they will not intersect at any point, and hence you will have no solution. Okay. So not only unique solution, Vignesh, it is depends on the system we are trying to study. So if the system is giving such equations in which they have a unique solution, you'll find that. If they superimpose entirely, you'll find infinite solutions, and if they don't, you'll find no solution. Okay. And what Tejal also told, that we are predicting the solution basically. Yes, ultimately we are just predicting the solution. So sometimes, as I told in my previous classes, that all the time we are not able to find the exact solution. So in those cases, we will try and approximate. We'll find an approximate for the original solution, and we are predicting what might be the solution. Okay. So we'll take a broader picture here and let's try and understand this. What are we actually doing when we are solving Ax equal to b? Okay. So whenever we study a physical system, like suppose you are trying to study growth of cells in a particular medium, or you're trying to study when the ball is dropped from a particular height, what speed does it attain once it reaches close to the earth, so on and so forth. Whatever physical system you are studying, they are complex systems, right? They are physical systems, so they are complex to study. But what we can do is we can simplify these systems and we can reduce it in the form of some equations. Okay, and what equations are these? These can either be written in the form of linear equations that we have been studying so far, or they can be in the form of nonlinear equations, or even differential equations, or there are other several types of equation. Okay, so what we are trying to do after we write the equations is that we try and find a solution for these equations. Okay, now finding the solution is, we have written it in terms of Ax equal to b, and when we are trying to find the solution, we try to find out the value of this vector x. But why this Ax equal to b is so important, and why are we trying to find out Ax equal to b, right? So the idea here is whether they are differential equations or nonlinear equations or any other complicated form of equations, they are a bit complex to solve and they can be all reduced to linear equations. Okay, once they are reduced in the form of linear equations, you can write it as Ax equal to b. And in all these classes that we are learning, we are basically learning techniques to solve and find out the solution for Ax equal to b. Okay, so that is the major motivation that we need to remember, why we are going behind learning all these numerical techniques in order to solve Ax equal to b. Okay, so with that motivation in the background, we'll get started with today's first technique, which is Jacobi iterations. So I guess this is one of the techniques which is there in the present week's assignment, right? So we will go through the method, the algorithm, so that you can solve the assignments. And if you have any doubts, please write back to us, okay? So any confusion so far? You both are okay?
Okay, there is no confusion.
Okay, ठीक है. So let's go and get started with the Jacobi iterations. And Jacobi iteration is an iterative method. Okay, before we go into the details why it is called an iterative method and so on, we'll just keep it a question for now. Let's solve the Jacobi method and we'll find out for ourselves that why is it called an iterative method. Okay, so we will be solving Ax equal to b, where the matrix A is given as 2, 1, 0, 1, 2 and 1, 0, 1 and 1. Okay, and this example is taken from the book Numerical Methods for Engineers, S.K. Gupta. If you want to go back and check how they have solved it, or just read the book in general, you can go back to this book. Okay, so in this example, we have A, we have X, and we have X. Okay, we have the X vector, we have the B vector, and we have the initial values of X. Okay, whenever it is an iterative method, we are always given what X values we are supposed to start solving with. Okay, so this is the initial values. So what do we basically do in this method in order to start and find out the first iteration of x1, x2 and x3? What we'll basically do is, first let us write down the equations. Okay, with the help of the matrix, let us write down the equations. Can any of you just unmute and tell me what will be the equations from this A and X? Did you understand the question?
2x1 plus x2 equal to 1.
Yes, 2x1 plus x2
x2
equal
plus
to 1.
x3, 0x3 equal to
0x3. Fine, I'm not writing that. That's okay, no problem.
plus x1 plus 2x2 plus x3 equal to 2.
Very good. Okay.
x2 plus x3 equal to 4.
x2 plus x3 equal to 4. Okay. So now what we will do in this method is that, using this first equation that we have written down, 2x1 plus x2 equal to 1, we will rearrange and write what will be the value of x1. Okay, and how do we rearrange that and write? I'll write in a different color. How do we rearrange that? X1 will be equal to 1 minus, so if you go from this equation, it will be 1 minus x2 divided by 2. It will be 1 minus 2 equal to 0.5. Okay, so similarly, Tejal, can you unmute and tell me how will you rearrange and write x2 from using the second equation B?
Yes, ma'am. 2 minus x1 minus x3 divided by 2.
Very good. 2 minus this divided by 2. Okay, so what will be the values? It will be 2 minus, okay, so one point, I'll take a pause here and I'll just remind you people that in this Jacobi method, when we are trying to find out the first iteration of these values, what we are using is only the values of x from the previous iteration. Okay, just like you were trying to find out x1 of 1, you used x2 0, right? So x2 0 is basically this initial value of x's. Okay, so now you tell me, Tejal, this is going to be x2, x1 0 and x3 0, right? So what are the values? 2 minus, can you tell me?
0 minus 0.
0 minus 0? No. Okay, you're getting confused. See, what is the value? I'll write it here clearly for you. See, x1 of the 0th iteration is equal to 1, this value. x2 of the 0th iteration is 2. 0th iteration basically means the initial values, okay? And x3 of the 0th iteration is 1, okay? So now you tell me, what will this be? 2 minus?
2 minus 1.
Yes,
Minus 1
1 divided by 2.
divided by
So that will give me
0.
0. Done. Okay. So similarly, I'll just write x3 for you all. x3 is going to be 4 minus x2 of the 0th iteration, which is going to be 4 minus 2 is equal to 2. Okay. Now, this is one of the points that we are supposed to note in case of the Jacobi iterations. That is, we always use the values from the previous iteration. Okay. So, if we quickly solve what will be for x2, you will find x1 of the second iteration is going to be 1 minus x2 of the first iteration divided by 2, which is going to be 1 minus, can anyone tell me what is x2 of the previous iteration, x2 of the first iteration?
0.
Right, very good. So divided by 2, this is going to be 0.5. So as you have understood, I'll just quickly write this. So this is going to be 2 minus x3 of the first iteration minus x1 of the first iteration divided by 2, which will give me 2 minus 2 plus 0.5 divided by 2, which is finally going to give me 0.25. Okay, and x3 for me is 4 minus x2 of the first iteration, which is going to give me 4 minus 0, which is basically 4. Okay. Now, we have to understand something, that we have done only 2 iterations so far, right? So now you see, performing the 2 iterations, what you get is the value of x1 has come out to be 0.5. The value of x2 has come out to be 0 and the value of x3 has come out to be 2. Okay. The second time we did it, we got the value of x1 as 0.5, 0.25 and 4. Okay. But try and see what is the true solution. The true solution for the 3 equations that we have written down is basically 3, minus 5 and 9. Okay, now can you compare that how far we are from the true solution? Just after doing 2 iterations, we are way far from the true solution. Okay, so in order to do this, we have to continuously keep using the values of x's from the previous iteration and compute the values of x's for the next iteration. Okay, so for time purpose, what I will show you is an Excel sheet where I have computed for several equations and found out whatever is coming. Okay, so tell me if you guys can see the Excel sheet. Just give me a minute. Okay. So tell me if the Excel sheet is visible to you all.
Yeah, it is visible.
So now see this that I'll again